Hello everyone, thank you for watching Alibaba online conference. This is the Mani. I'm responsible for database on international market. Glad to have this opportunity to discuss about the next generation database, born from Alibaba's Double 11 event and became world-leading cloud-native data management system. Today's talk divided into 4 sessions. We'll start with how the Double 11 event posed the unique challenges to the team, and the database team not only address such challenges, but also go beyond to build the cloud-native system for our cloud customers. First, let's talk about Double 11. As a global company, Alibaba provides service from entertainment to social media, from financial to logistics, and the core e-commerce is often recognized by the world's largest shopping festival, the Double 11. Exactly how large we are talking about? Let's look at it from sales perspective. There are 3 24-hour online sales events: Alibaba Double 11, Cyber Monday, and Amazon Prime Day. The sales data shows that in year 2018, Double 11 had total sale of more than $30 billion, which is close to 4 times of Cyber Monday and more than 7 times of Prime Day. Let's translate the business sales figure back to the technical term. I was fortunate enough to be at Alibaba headquarters and watching this chart was drawn on the screen. At the middle night of November 11, the first second, the workload grows 120 times. It's like I was sitting in front of the calm ocean, the wave was mild, and everything was quiet. Suddenly, tsunami came with a wave over 100 meters high, which brought in the extremely workload and stress to the system, including database. It demands elasticity, extreme performance, and as a result, close to 500,000 orders was completed within the very first second. To evaluate the database system, usually 2 key performance indicators are measured. The throughput. For example, the 500,000 orders was completed within the second. And the response time, also called latency. That is how fast a task is completed. I borrowed this chart from the Alibaba paper published in this year's Sigma conference. The red line is the one we just discussed, and the blue one represents the database response time. It shows although the workload jumps 122 times, the response time is well under 1 millisecond, actually close to half millisecond average. What exactly does that mean? That means such heavy stress and workload is totally transparent to end user. In another word, when the world's largest tsunami comes in, our customer feels nothing. They can place order as kids play in front of the calm ocean as if it is a normal day. Now, let's summarize the top challenges Double 11 failed. While we're talking about something happened on the surface, this is the 122 times workload that demands extreme elasticity. There is also something didn't happen, system failure, which requires a high availability to prevent that. In real dollar term, that means $21 million every minute. And behind them, the efficiency of storage engine that match Double 11's data access pattern. This challenge, in the early year of Double 11, the team already realized that Oracle was not the solution, and the database development team has to take care of them. Next, let's talk about the technologies Alibaba applied to address these challenges. First, the elasticities. To take care of the 100 times workload, Alibaba needs to prepare enough hardware resource, particularly computation capacity. In the past, DBA have to physically move the service from one location to data center that support Double 11. Realizing it is not sustainable, Alibaba began its cloud R&D almost the same year as Double 11. Particularly on database, computation and the storage engine are decoupled. Computation nodes are balanced for write request and read-only request, and the storage engine is built on top of Pangu, a distributed file system. Under such architecture, computation nodes are stateless, can be flexibly deployed on cloud using container technology, and the distributed file system provides unlimited storage capacity. Both computation and storage became resource pool instead of individual physical machines. The end result is hardware occupation was reduced from more than 3 months to just a few days. Serving billions of users with years of data, the storage efficiency directly impacts the bottom line of business cost. That request leads to layered storage. One sample case study demonstrated the database access pattern. The access frequency dropped dramatically after 15 minutes of data initialization, and the probability to be accessed again is less than 2% after 7 days. And on another time, in addition to the classic memory plus hard disk as storage, new hardware such as MRAM, 3D X-Point, Flash SSD provide new options. The newly designed storage engine takes advantage of that. It converts all writes to append-only operations to achieve high write performance. In memory, it is map-table using skip list and with warlog for persistency, and flash uncompressed data to MRAM as hot data. Later on, when data receives less access, that is getting cold, it is compact and compressed to more efficient format, such as columnar store to hard disk. The third one is to ensure nothing wrong happens, at least from user perspective. In database terms, it is the high availability with hundreds of thousands database instances running for Double 11. Statistic-wise, some failure will occur. How to automatically fail over and totally transparent to end user is the key. Here, Paxos protocol is implemented for such goal. Under such distributed consensus algorithm, each database instance serves as different roles. The leader is the primary one, sometimes called master. The follower is also a complete DB instance as hot standby. Logger only store DB logs. The 3 roles have voting rights in the case of failure. There is the 4th role called learner, which serves as a unit for read-only tasks. The graph at the lower left corner simulates one of the Alibaba's internal business. Shanghai as the data center with leader. We have 3 followers deployed in 3 regions and 1 logger also in Shanghai. There are totally 5 voters to satisfy Paxos algorithm. There are 2 learners in Shenzhen and Zhangbei to serve read-only tasks. The roles are interchangeable. For example, the 2 followers in Shenzhen and Zhangbei can be changed to learners, which is common for performance reasons. Also, since data replication speed directly impacts data availability, data stream is dynamically paralleled according to network bandwidth and speed, and also configure the deployment configuration. In addition, with the flexible deployment, the system not only guarantees high availability, but also push data close to user, which improve the response time. Double 11 comes to the 11th year. Along the way, the technologies gradually matured into database products. Let's look at the three architectures of database. The first one is the traditional single instance architecture. The DB box contains CPU and memory on top of disk storage. Traditionally, CPU, memory, and disk are bundled together as a single server. Here, MySQL is the typical single instance DB. The latest cloud-native database can be represented by the one in the middle. There are two key points here. One, the storage and the computation are decoupled. Another is to achieve massive storage capacity. How to do that? Typically, a network management system is applied to make the distributed storage server as if it is a local disk, but with massive space, so we can get the elasticity. And all DB instances share the same state, which avoids the complexity of distributed transactions. The typical products are AWS Aurora and Alibaba's PolarDB. Well, shared storage does carry the limitation as currently the network support up to 20 DB instances. More than that, performance may decline. Hence come to the shared nothing architecture. It is the collection of single instances under a management layer. The data is sharded to all instances. Shared nothing can provide virtually unlimited horizontal scale-out. However, it also introduces the complexity of cross-shard transactions and query. Alibaba's AnalyticDB are using this architecture. So did Google Spanner and AWS Redshift. Next, let's discuss single instance DB MySQL, which was initially released in 1995, almost a quarter century ago, and it still lives a long, rich life. Currently, it ranks top 2 of relational database system, and the top 1 amongst the open source system. For single instance MySQL, Alibaba Cloud provides 2 deployment architectures. Let's talk about the first one. Active in a single region with 2 availability zones. In this picture, there are 3 MySQL instances are deployed to achieve both workload balance and high availability. In AZ1, we have 2 MySQL nodes, one for write and read request, another one for read only. In AZ2, one MySQL standby node is set up to provide cross-AZ high availability. One can set up this by just a few clicks on alibabacloud.com, and a proxy layer is made it totally transparent to user application. By automatically routing the read and write request and point to the standby node in case of failure. The deployment is also flexible that read-only node can be added or removed according to the business needs. Commonly, we see 3 to 5 read-only nodes for a typical OLTP workload. The second deployment is the enterprise version of MySQL. If you feel this chart is a bit familiar, you're right. Actually, it's the vanilla version of the X-Paxos we just discussed a few minutes ago. After well tested by Double 11, we put the product on Alibaba Cloud. The enterprise version has 3 nodes, serve as leader, follower, and logger in 3 AZ. Also, it provides strong data consistency and guarantee zero data loss during single AZ failure. Also provide faster failover and with lower costs. While Alibaba started with single instance MySQL, and many internal workloads still using the above two high availability setups. However, single instance MySQL does carry some shortcomings. Just to name a few. When DB size reached 3 TB, sharding became the only secure options, and it often takes hours to back up. Simply edit a column may take 3 hours, and often we do not have such maintenance window. End of the day, we need a OLTP system with high throughput, low latency in high concurrency environment, and also need that be on top of massive data. Here comes the cloud-native PolarDB. This is the shared storage database we just discussed earlier. A technology called RDMA, Remote Direct Memory Access, is applied here. RDMA permits high throughput, low latency networking, which manages the distributed storage servers. The diagram shows the details with RDMA in the middle to provide a high-speed network. There can be many data chunk servers under RDMA, which acting as if they're just one huge local disk to the upper SQL layer. To ensure the safety of data, the data is broken into chunks, as demonstrated as ABC here. Each chunk has its replicas under distributed consensus algorithm, such as raft. Actually, PolarDB is using enhanced parallel raft, which maintains 3 copies of each data, provide high availability for mission-critical workload, such as financial business. The upper layer is the computation, the DB box which contains CPU and memory. Among the DB box, there is a primary one, also called master node. This node will serve both write and read. Others will be read-only node. PolarDB can manage up to 100 TB of data and serve millions QPS, also with backup and restore and expansion within minutes. PolarDB actually has 3 deployment versions. One compatible with MySQL, another one with the PostgreSQL. The third one with enhanced feature and highly compatible with Oracle, so that most users can easily migrate their application over to Alibaba Cloud. Here is the architecture diagram from layer perspective. To balance the workload among the computation node, there is an intelligent Polo proxy which routing tasks to different nodes. Certainly all write tasks go to the primary node, but all the read-only ones will be balanced among the read-only nodes. At the bottom, the distributed storage engine we have the PoloStore. On top of that is the PoloFS. PoloFS is compatible with Pexis file system, so that it can seamlessly connect to SQL engine to MySQL or PostgreSQL, which in return ensures the SQL compatibility. Well, with the data size growth, Alibaba needs to apply business analysis and extract values from them. For example, doing revenue reporting, or for e-commerce to monitor users' activity at the peak seasons, helping supply chain sector to optimize logistics and delivery, support retailer online and judge promotion products on the fly. That introduces the online analytical processing, OLAP, providing interactive analysis on massive data, often petabytes of data with 100 million queries daily. This is the AnalyticDB, the one leveraging the third shared nothing architecture for massive parallel processing. For a real-time data warehouse, when we have massive data, There are usually two choices to process massive data. One is the big data solution, such as Hadoop MapReduce, which suffers the issue called curse of the last reducer. That is, everyone has to wait for the slowest test to synchronize the result. Another solution is the data cube for traditional data warehousing. Basically, it uses ETL and the preset dimension to pre-analyze the data. The issue is that if the interactive query does not match the dimensions, sorry, we are out of luck. AnalyticDB is using database technologies to resolve the big data issue and no need to pre-calculate the data cube. It is using the following technologies. First, AnalyticDB developed its own row-column hybrid storage. Row storage handles insert, update, delete, and the column store is highly efficient for analytic processing. The second one is enhanced on index. Traditional database index such as bpath tree, hash index are expensive. AnalyticDB using new indexes such as inverted, bitmap, and vector index to significantly reduce cost of index. The third one, massive parallelism processing and DAG optimization, providing large-scale distributed calculations. With that, we are looking at the typical scenarios. Internally, Alibaba's Damopan is the marketing platform to support e-commerce. It analyzes 13,000 tables, more than 70 terabytes of data. And during peak time, more than 1.2 million writes was processed and analyzed without data tube. It supports interactive query on real time at second and even millisecond level. Externally, we bundle with DTS, the data transmission service, to move data from other data sources such as Hadoop, Oracle, NoSQL system to AnalyticDB, achieve real query result, and output to other various of BI tools for data scientists and executives to make a critical business decision. Well, on the last sector, but not the least, let's look at the complete picture of Alibaba Cloud Database at the current day and how it stands globally, and also the future of cloud databases. Here is the whole picture of all database products and services. From the top, the tools and utility, to our database engine products, from TP to AP to NoSQL, and the operation platform including self-developed and also open source and third-party products. Besides the engine, on the utility side, DTS is popular for data migration and transmission, and IDEM assisting customer to migrate from commercial database onto cloud. And I like to point out, Alibaba always brings open source community, and that is why our products such as PolarDB and AnalyticDB provides different compatibility versions to MySQL and PostgreSQL. And we will also contribute our technologies back to open source community through AliSQL. Actually, the MySQL on Alibaba Cloud is the AliSQL and improved version of our open source. As the key component of the cloud, database link the infrastructure layer, the S, to the intelligent application layer, the AI SaaS layer. And in artificial intelligence is the next breakthrough for database system. So let's touch base on Alibaba's approach on artificial intelligence. Database and AI machine learning cross paths in two ways. One is inside the database kernel. Cost-based model can be optimized by introduce machine learning to generate a better execution plan. Another way is the administration and operational platform, leveraging AI in daily operation, such as monitoring, system tuning, resource scheduling, Alibaba implement self-driven database platform to monitor the system, collect performance metrics, and feedback to the system. Let's look at one example. Individualized buffer pool tuning. Often, database buffer pool is fixed. However, workload changes all the time. Through this self-driven platform, IPTune monitors the workload and changes buffer pool size accordingly. Today, it supports more than 10,000 instances with 27 terabytes of memory saved daily. This tool lowers the operational cost and totally transparent to the business. With all this, database of Alibaba Cloud certainly received notice globally and by the analysts. Gartner view our OLTP solution among the visionary. First view OLAP solution as contenders, and overall, database as a solution among the strong performers, which also reflect on the revenue, where Alibaba jumped over Oracle to be the top 3 in the world with 3-digit year-to-year growth. I believe during the journey to cloud, with the whole stack of products and service, Alibaba will be able to find the right database solution to grow your business. Let's partner together with the latest technologies and cutting-edge innovations, give the best service to our users and customers. Thank you for watching.